Hello everybody. This video is designed to help you with direction. And so what I've done here is I've created a little warm-up. I've got a kind of complicated looking diagram here, but what we're going to do is we're going to figure out what are all the angle measurements of all of these numbered angles right here. Okay, that's what it says. Find all the angles in the diagram below. So it says given the measure of angle 4 is 50 degrees, measure of angle 9 is 33. And then I put this table over here so we can just start writing down the angle measurements. So angle, and I actually can put it in the diagram as well. So measure of angle 4 is 50 degrees. It's 50 degrees right here. Measure of angle 9 is 33. Okay. Now the purpose of why we're doing this is the diagram that you're going to end up drawing when you're doing a word problem. So I'll actually link this document on my website or on Google Classroom for you to access that. All right, so from those two given angles, I can find the rest of them, and I'm going to show you how. This hint is really important. Lines that appear perpendicular are perpendicular. So that means this north-south dotted line and this east-west dotted line are perpendicular, which means that this is 90 degrees, this is 90 degrees, and this is 90 degrees. And that also means that 4 and 5 add together to give you 90 degrees. So since this is 50, this must be 40, right? Those are complementary angles. Now, to find the other angles, if we look straight across here at this corner, we've got angle 6 and angle 7. Angle 6 right here is an alternate interior angle with angle 5. And that word, those words, alternate interior angles, that's a vocabulary word from geometry. You should have learned that two lines cut by a transversal, when they're parallel, will be congruent. So angle 6 is going to be 40 degrees. And angle 7 is going to be 50, right? All right, and so then angle 8 is 90 degrees, 11 is 90 degrees, and 10 we're going to find the same way, right? So 10 and 9 combine to make 90 degrees. Since that's 33, this one would be 57, right? And then angle 12 is an alternate interior angle with 9, making it 33 degrees. 14 would be 57. And then these three are 90. Okay, so we have all these angle measurements from just given 2. And that's really going to come in handy. So I'm going to expect that you draw this type of diagram when you're solving problems like the one I'm going to show you now. So now we're going to actually apply that. And the only reason I'm not writing it in here is because it's kind of awkward the way that my camera is set up right now. But hopefully that's clear enough that you can kind of see what angles are where. Okay, so this is the word problem that we would be working on. Okay, we've got a ship leaving port. I feel like this is kind of a classic problem that I feel like I had nightmares about trying to understand when I was doing math myself in high school. So we've got a ship leaving port on a heading of north 50 degrees east, traveling at 12 knots for 4 hours. It then turns to a heading of south 33 degrees east, traveling at 10 knots for 3 hours. Draw a diagram representing the ship's path. Okay, so a lot of things here is like definitely confusing, and it actually turns out this is going to be the diagram we draw. Okay, and I'll show you. I'll try to unravel some stuff. So first we've got a ship, so some sort of boat is leaving a port, and it's heading north 50 degrees east. So that's one first thing that we need to figure out what that actually means. North 50 degrees east. So what I do is just like that diagram up there. I'm going to start with a dot. That's going to represent where port is. And I'm going to put dotted lines in the north-south direction and the east-west direction. And that's going to help orient myself around that starting place, because the first direction that it's going is north 50 degrees east. So that the way that you should read that is, this is straight north. This would be north 0 degrees east. So north, and then the 50-degree angle is from the north direction towards the east, right? So it would look something like this, okay? And here's the 50-degree angle right there. There's your 50 degree, okay? Which is exactly what we had in the diagram above, okay? So now this line segment right here actually is a distance, okay? And that gets us to this part here, this 12 knots for 4 hours, okay? 1 knot, by the way, that's a nautical mile per hour. Right, so this is actually 12 knots is a speed. It's not a distance. A knot is a nautical mile per hour. All right, and nautical mile is not like a a regular mile like you would run on a track or a metric mile. So when it says 12 knots, you can think of this as miles per hour, but it's actually nautical miles per hour. So for 4 hours, so that's speed times time, that would be the distance that it would travel. So we're going to get a distance here. Imagine if that was 12 miles per hour for 4 hours, you would just multiply them together, which would give you 48, and that would be nautical miles. The way you can abbreviate that is a capital N and a capital M, okay? So that's 48 nautical miles is how far that boat traveled, all right? So then this boat turns. It says it turns to a heading of south 33 degrees east, and this is why it's important to then reorient yourself around the north-south directions and the east-west direction. So I put those dotted lines there to help figure out maybe what some of these angles are, but also to figure out this new angle, right? So it's south. Where's the 33 degrees? So it's straight south, 0 degrees east or west would be not moving left or right at all. 33 degrees towards the east now. So it's going to look like this. And here's your 33 degrees. Again, it's the exact same diagram we had above. Okay, so there's your 33 degrees. I'm going to zoom in a little bit here. Hopefully this will be able to see it a little bit. So there's your 33 degrees, and then it's right here. Here's the boat. Here's our north. Here's our south. Here's our east. Here's our west. I'm not sure if anyone actually showed me how to do that or if I just had to do a bunch of these problems and figured it out, but those dotted lines really come in handy a lot, all right? So that's 33 degrees south, or south 33 degrees east, and it's traveling at 10 knots for 3 hours. Again, 10 nautical miles per hour for 3 hours. So that's 30 nautical miles, all right? And draw a diagram representing the ship's path. So this is the ship's path. Now, I will say that there is an additional question that will be asked, and that usually asks about how far is the ship from port. If this is port right here, and here's the ship now, after, what would that be? That'd be 7 hours of travel. That's where the ship is. So often what I will do is I'll have this initial diagram, and then I'll draw another one. So I'll take this and I'll draw another diagram, just kind of without those dotted lines, just to kind of draw it like this, right? And this diagram is just a regular old triangle, and we can start asking questions about this triangle, like this would be where the boat is after 7 hours of travel. This is the port, right? I basically just connected this to that. And I could ask the question, how far away is it? So what's this distance x? And since I have this distance 48 nautical miles, and this is 30 nautical miles, I would need this angle, right? Because then this would be a side angle side triangle, and I could find this opposite side here. So what is this angle here? And that's why that other diagram came in handy. If this is 38, we found this one earlier. This one's 50, right? So 50 and 38, that makes 83. That looks like an 8. It's 50 and 33, so that makes 83 degrees. So like I said, this is a side angle side triangle, and I can use the law of cosines to find x, right? The law of cosines is something we practiced before, so I can actually find how far away the boat is from that. And that all comes together from understanding what a knot is, and then drawing these diagrams in a way where you can use that divider to figure that part out. Because a lot of people make that mistake here, and they don't know what angle to put there. They either put 50 or they put 33, but I have to combine those two in order to figure that out. And so that should be able to get you started on some of those word problems. At least it'll help you understand direction a little bit more, and it'll help you understand what knots actually are. I hope that helps.